First, I'd like to start off by thanking Roll-to-Roll Converters Association for having Micromatic as a presenter for the 2023 conference. My name is Jeff Smigel. I am the Director of Sales and Marketing for the Micromatic Closed Chemical Systems Division. And I'm extremely excited to share with you some new innovative technology for mixing called the ProBlend Closed Mixing System. Over the next 20 to 25 minutes, I'd like to cover the following topics: about Micromatic, what is the ProBlend, how is it different, how it works, system requirements, and I'll share with you a case study success story by a printing company called Interprint. And then we'll end with a Q&A. So who is Micromatic? If you've ever tapped a keg or back in those college days, had a keg stand, or were at the local pub having a draft beer, you've interfaced with Micromatic. Micromatic manufactures 80 to 90% of the world keg valves, and we're the leading global company of closed systems. Little history: back in 1980, Dow came to Micromatic with a need for the technology on the beverage side for a termiticide. And obviously you can't use the beverage products for industrial chemicals, so this opportunity led us to the evolution of our Closed Chemical Systems division and our portfolio of closed systems. So I always like to start off by saying, why does Micromatic exist today, and what do we set out to do or achieve or help to solve in the world? So everything that we do, we believe in protecting people, products, and environment for a cleaner, safer, more productive tomorrow. What we do is we help companies work more efficient, effective, and economically to help chemical manufacturers deliver formulation to end-use applications, to perform as intended, and advance the world to a more sustainable future. So here I want to talk about the value of closed systems, and looking at these photos, put it into perspective for you, is the far left is a closed package, and this is a top view of a 275-gallon IBC container with our valve installed in that 6-inch center cap. The next photo is one of our fill coupler connected to the container. And you will notice off to the right of that red handle coupler is a hose, a clear hose. And what that is that is the vapor recovery hose. So as you're filling, you're displacing the air out of the container. And this is the vapor recovery line, which allows you to have a closed loop system, which is closed liquid and vapor. Moving to the next photo, we have closed mixing. And this is the product that we're going to talk about in this presentation. It also quickly connects in to where you could mix the contents of that container as well. Once that's disconnected, you could then couple into that same container with a dispense coupler, which will then allow you to dispense the product in the container out of the top of the container. So looking at everything from a packaging and handling perspective, it's always closed, and this gives you and delivers ultimate control. Another point to make is that the system is a dry break design, which is less than 2 milliliters of product exposure. And the value it delivers is that it minimizes spills, stains, and exposure while maximizing the product efficacy. And in your world, I'd call it the ink or colorant efficacy. Also protects the worker and the environment from exposure. And if you are utilizing our closed dispense system, you can achieve a greater yield with our technology. So looking at the complete package, what's illustrated here is a drum, and we'll start on the far left. And then the items I'd like to really focus on is the container valve. And the container valve is integrated with a down tube and a mix foot. So those three components are installed into the container and remain in the container throughout the service life of the container. So once installed, you have the ability to have a single connection to simplify multiple functionality of that container. So you could connect to the container valve with a fill coupler for filling, and then that could be at the fill site, obviously, or manufacturer. Then it goes through distribution out to the distributor, or let's say the print company, where they're going to mix that ink before it is applied to the press for printing. and then they will disconnect that, and then they could quickly connect into the same valve with a dispense coupler to then bring it to the press. So everything has a quick and easy format to work with the container and to make sure that it's in ultimate control at all points of packaging and handling. So this is a slide that really illustrates and outlines some logos of companies that we work with, different customers in a variety of industries and chemistries or applications. And the one to note that we're going to share with you, the case study or the customer testimonial, the company Interprint, which is located on the far right. But also you may be familiar with a couple of these other logos or not. But if you look at it, maybe there's some hazardous chemicals, there's some purity products, there's some specialty chemicals, but we do work with a wide variety of companies and a wide variety of formats, applications, and chemistries. So getting into the product of that we wanted to speak to or share with you about is we are the first of its kind, and it is the integration of this mixing technology with our closed systems. And really, if you're looking at this, I wanted to illustrate the fact of how small the unit is compared to your hands. So it's a very interesting technology that's fairly small, but the impact is quite significant. So what is the probe blend mixer and how is it different? So I'll start on the far left where it says air operated. Right above that it says pulse air. So a little bit of history here is pulse air is the technology that we integrated with our closed systems. Pulse air has been proven for mixing over a few decades, and the technology and their format is usually in tank farms, but we integrated it with our closed systems to work with packaging from, call it 15-gallon drums all the way up to mini bulk containers as well. It is air operated, and when the print world says air is a bad thing. So we want to make sure you understand that it is air operated without developing in-trained air. Also, it's important to note that it does not introduce any foaming, frothing, or even shearing of the product. It utilizes time pulses of pressurized air that quickly and completely mix the contents of a container without the introduction of entrained air or foaming. So the picture on the far left is an inside view of a 275-gallon IBC, and the product is glycol, and we used a GoPro with a backlight to really show you the height and the difference of how big that bubble gets in that container. And a couple slides down will show you that video on action. So to the right, there's complete mixing. So what we wanted to illustrate was a before and after. There was really the beginning of the before, maybe a minute in, just starting the process of mixing. And then the second image down below shows about 7 minutes in, which was about 80 to 90% completely mixed. And our ProBlend mixer is quicker, more efficient, and effective than traditional mechanical mixers. The other important thing to note is that it achieves superior ink mixing by maximizing color efficacy in the shortest amount of time, cost, and energy. And we'll talk about time, cost, and energy when it comes to sustainability and really those sustainability goals of organizations today. So talk about a multifaceted value proposition. It not only reaches the objectives of the mixing, it does so from a sustainability point as well. Okay, so what I'd like to do here is focus on the top image in green and to really show the differences between a closed system and an open system. The closed system, as you can see, there's a portion of the equipment on the top that's supposed to be a dispense or fill coupler that's not connected to the container, where there is a dry disconnect, so there is no exposure to the green liquid or the green ink. Whereas the open system, the probe or let's call it the mechanical mixer, is inserted into the container, and once the container is empty or done mixing, the prop is pulled out. And when you take the prop out, you have exposure. So you have exposure to the worker, the environment, the risk of stains, spills, falls, slips, all the above. And then on top of that, if you look at it from a fully burdened cost or operational expense, you're talking about how much productivity do you get within your organization and how much time is spent on cleanup or the utilization of 2 workers to mount and to change out containers of ink. So moving to the bottom picture, you'll see a team member here holding the ProBlend. So you can see the size relationship to the mechanical mixer on the right. It's could be operated by 1 worker. It's easy to connect from a dashboard perspective or OSHA. You're not carrying much weight, if any at all. And the way you connect it to the top of the container is you just reach over and you quick connect it in. Whereas the open system on the right, you have 2 workers or 1 worker that has to maneuver this motor with a prop into a container. It has to be mounted down. When the container is empty, you have to reverse that process. And then there's cleanup and all that good stuff associated. Another point of interest is the ProBlend mixer can be used with multiple containers with multiple colorants or inks without the introduction of cross-contamination or product adulteration. So the mixer could be used on, let's call it a yellow ink, and then when it's done mixing, you could then quick connect it into a red colorant, and then so forth and so on to different colors. So the product or the mixer never gets wetted, meaning it doesn't touch the ink, and therefore you don't have cross-contamination. So how it works, the power of the bubble. So if any of you looked on the website and saw the title of this presentation, it's called The Power of the Bubble, and it's very interesting because when I learned about this technology and saw Pulsar and read up on them on its proven technology, is they're utilizing time pulses of pressurized air. This time pressurized air creates a level of kinetic energy in a container. And even though our mixer is in the center of the container with 1 mix plate, it actually has the ability to roll. Once that bubble breaks surface on the top, it rolls towards the outer edges, reaches the corners, and then from a frequency standpoint, from 1 pulse per second, you create this kinetic energy in the container that creates a high level of mixing action. One thing to note again is the fact that the ProBlend mixer does not shear your ink or your formulation. It does not generate foaming, nor does it generate or develop entrained air. Comparing it to a mechanical mixer, there are no gears and no motors like the mechanical mixer where those have to get replaced, they get burned out. There's no mess because it is a closed system. And based off of the technology, you have complete mixing, and through the quick cam connection, it's simplified mixing. It's very simple to use and very effective. So now I'm going to share with you a video of what it looks like inside of the container. Again, this is glycol, and this is, I would call it 55 PSI at 1 pulse per second. And what you'll see is the surface level rise to a significant degree. One important note is that there needs to be a level of headspace, so this bubble can actually rise and fall. You want to make sure there's enough space to the top of the container for this action to perform. Pretty significant how that bubble comes up. And if there are any bubbles of air, those are quickly dissipated through the top. So from an operational perspective, the ProBlend mixer requires less than 125 PSI. So if you have any shop air or anything, you could regulate it down to that pressure. And if you are utilizing the ProBlend in a remote location where you don't have shop air or any lines coming down, you could retrofit into. It only operates and requires 2 to 4 CFM. And if you look at it from an energy perspective, that's not much energy, so it's pretty efficient. But because it is a level of innovative precision technology, it does require clean, dry air and oil-free. And so what we also recommend is that in line before the probe blend to install a coalescing air filter, because if you have some older compressors that may have a high level of rust, or may have some issues from a debris standpoint, or generate a higher level of water, you want to make sure that you protect the technology by capturing that before it enters into the probe blend. From a retrofit perspective, on the probe blend, it has a male 1/4 inch male connection to where you can connect with a female quick connect fitting from existing air source, or you could get something, something standard from an equipment standpoint. So looking at once the product is mixed in that container, how are you going to dispense it? Based off of how you operate and intend to operate, we have two solutions. One is continuing to use the bottom valve dispense, or to utilize our top dispense. So on the left, you'll see bottom dispense, where the center cap has two openings. One, you install a vented bung cap, and the other is with the probe blend mixer. And after you're done mixing, you open the vent, so then you could pull product out of the bottom, and you do not panel the IBC, and that product will flow smoothly. On the right, you'll see top dispense. There's two different types of solutions, and the one I want to show first is the middle one, where you have two valves. You could dedicate one for dispense and one mix, or what you can do is, if you look at the far right in the drum, you could utilize one fitting to mix and dispense. So example would be, you would mix for 3 to 5 minutes, or call it 12 to 15 minutes. Once you're done mixing, you disconnect the mixer, and then you couple in with your dispense coupler. So it makes it quick, easy, low cost, and very effective. So we have solutions to retrofit bottom dispense or top dispense based on your operational needs. Next is when you're dealing with inks and polymers and types of different formulations. You may be dealing where you need a static mitigating system for flammable and combustible liquids. So we have two solutions here for your drums and for your IBCs. So on the far left, you'll see on the drum, they look very similar, and they really are. You're looking at a stainless steel valve with a HDPE down tube, which is the white tube on the left. And out the bottom, you'll see a red wire, or a red line. And what that is that's a grounding wire that's welded to the stainless steel valve, which travels in the liquid path, where you get a charge built up so you can dissipate that charge. And the grounding wire always is remaining in the liquid, so you maximize conductivity. And at the very top, where the valve is, on top of that, we have a terminal and a way to connect the valve to a grounding or bonding wire. Looking over to the right, you'll see a very similar type of connection, but this just shows how it looks like in a 275 gallon IBC. It's also important to note that Micromatic has conducted tests on the system from an ohms perspective, and both these systems are conductive. And we also, if required and requested, we do have third-party testing and reporting that we could provide to you. Now, from a production standpoint, we mentioned that there is a probe blend on a 1-to-1 basis. If you're in a situation where you'd like to integrate into a production environment, there is a way to put this into a series mixing. This illustrates a manual system where obviously it's done manually, whereas the second one you could integrate with a PLC system. So we could help you integrate that to some capacity, but we would work with third parties to make sure you're tying in with the same operating system or software to any existing let's say operations, and make sure that everything is put together appropriately. Now, when you do mix, you introduce air into the container, and then it needs to off gas out of the container. So if you do not want to have those vapors go into the general area, we do have the integration or the ability to capture those vapors to a vapor canister, maybe a carbon filter. You could even take that hose up to a hood and take those vapors out of the local vicinity. And then to the right, there's a rinsing and storage socket. So on a periodic basis, from a preventative maintenance standpoint, when you have scheduled downtime, you would conduct some sort of, let's call it maintenance with the Pro Blend, where you can clean the Pro Blend. You could make sure that it's operating at peak performance so you could get the benefit out of the mixer and it lasts as long as it possibly can. So here I wanted to share with you a few different companies that we work with, and they do offer mixing in different chemistries and formats, so I wanted to share that. So the first one is the company I'm going to share with you in regards to the case study customer testimonial, Interprint. They are a top global printing company for inks. The second one is the largest global ag chem company called Syngenta, and they utilize our mixer for their seed treatments. And then the next one is Yara. They're the largest global fertilizer company, and they use our mixer for micronutrients. And lastly, the interesting one is Sam Adams. Sam Adams uses our mixer in the beverage industry to mix the formulation or ingredients for their seltzer product, which is a Truly beverage. Lastly, the important note here is the two companies in the middle, the very bottom, the red text. You look at the value of the 275-gallon IBC is $30,000 to $40,000. So these organizations wanted a mixing solution to make sure that they had active ingredients consistent throughout the entire container, and they found that the Pro Blend was the most efficient, effective, and economic solution for them. Also, we have the ability to do co-branding or private labeling to make sure that we can, from a brand building perspective, is put a wrap on the Pro Blend, co-brand from a logo perspective on the dispense coupler. And here's an example of Syngenta, the seed care division. They use this mixer out in the field, so they had this case made with their logo, so they can show and illustrate to their customers that they're bringing innovative solutions, not only from a product or let's say a liquid perspective, chemistry standpoint, but also the equipment to deliver the best results. And then on the far right, there's a example of a piece of literature that was sent out to their distributors, customers, internal team on educating about the Pro Blend and SOPs from a installation, implementation, so forth and so on standpoint. So next we're going to go over the case study and success story by Interprint. So I have a little background in graphic design, creative management, and worked with printing presses and going to the press checks and all that good stuff, and 4-color process as well as spot color. But it was interesting because looking at Interprint's portfolio of solutions and how amazing their finished products are, is they utilize a lot of spot colors. So whether they're using a portion of that spot color out of a 275 or they're using all of that spot color, it requires mixing before going to the press or before application. The middle picture shows mechanical mixers, and it might be a little difficult to see, but you'll see mechanical mixers on each one of those IBCs, and there's a second story. So imagine the fully burdened cost of installing, replacing, cleaning, so forth and so on. And I call it the graveyard, which is the third picture to the right, which is really these mechanical mixers burning up, the parts and pieces failing, and just really the service life not being at a level that they should be at for this type of environment. So this was the before, and this next slide shows the integration of the Pro Blend and the after. So Interprint adopted the Pro Blend mixer, but what they did do is they integrated it with a manifold system where they connected it to a PLC, they automated it, and they connected to 6 different drums. And they had a sequence and let's call it a SOP or a process on how many minutes or the time frequency in which they mixed each one of these containers to get their formulation or their ink to the most accurate color possible. The far right photo shows the red-handed coupler connected to the container. So they could quickly connect in and out of each one of these. So once it's mixed, they could then process it accordingly and bring in new drums of ink. So before they adopted this technology, they did an A/B test. So the ProBlend versus the mechanical mixer. And there was a few tests conducted, but they did some samples and some tests and took pictures of different time frames. And looking at all three of these, they showed unmixed 5 minutes of mixing in the middle, and the one to the right is an hour of mixing. So even though they showed such a big variation between time frames, the sweet spot was between 12 and 15 minutes from unmixed to mixed, and the ability to get it completely mixed within 15 minutes was pretty amazing to them, and the level of accuracy, or how much better the ProBlend mixed the product to be more accurate than the mechanical mixer was quite significant. So the next slide here shows the sound levels. It's very important to note that it's interesting that the ProBlend does not require earplugs from an OSHA perspective, because it's below the levels of requirements for earplugs. And then also this slide does show you, the first video shows on a pulse rate basis, you'll see the gauge move back and forth. That shows the pulse and then it resetting to the appropriate PSI utilized. It also shows the dashboard with there's two different things. There's an on-off switch, and then there's a pulse rate. So you adjust that, and there's one more switch on the top that allows the pulse, the pressure, applied pressure. You'll see the gauge reset to the PSI applied. And then over to the right, if you can see inside that bung hole there, it's going to illustrate the rolling and mixing action in the effect. Moving on to another test would be on a more viscous product. This is a pearl ink. The other one that I showed you, go back a slide, this is a water-based ink, and then this is a different ink that is a bit thicker. So I wanted to start with the mixing results, and the report stated from Interprint that they did not have the ability to obtain adequate drawdowns for comparison. The viscosity was too high, but visual observation illustrated side-by-side video comparison. And I'll just highlight in the red, mechanical mixer was not as effective. So you'll see visually the differences. You'll see with the ProBlend, the rolling action and the larger footprint of movement of that liquid or the ink. And then with the mechanical mixer, you'll see the majority of that movement right there at the prop. You'll see a little bit of action outside of that, but it's pretty isolated towards right next to the prop. So if you look at something from a mixing standpoint, you'll see that the ProBlend actually has a greater footprint and diameter of mixing versus the mechanical mixer. That was the ProBlend mixer, and we'll move over to the mechanical mixer and you'll see the difference. And lastly, I'd like to end with looking at the ProBlend, and really from an efficient, effective, and economic standpoint, there's also a level of value with sustainability. So the ProBlend does reduce energy consumption, reduces water consumption, reduces waste, and reduces worker and environmental exposure. Also, from a responsible care and a product stewardship standpoint, it minimizes worker and environmental exposure. So if you're looking to meet all of those objectives or KPIs moving forward, it's really just the evolution of mixing, and we believe that we have a superior product in the ProBlend mixer versus a mechanical mixer. And lastly, from an onboarding or implementation standpoint, we have all of the resources for you and your team to get it onboarded and to utilize it and to be successful from a sustainable standpoint. So if you have any questions, please feel free to reach out to me. Here's all my contact details. I could also be reached on LinkedIn, and would love to learn more about your business and how we can be of service and help you with your mixing needs. Thank you for your time, and look forward to speaking with all of you. Thank you.